So, types of ions. Monoatomic ions consist of one atom. Mono meaning one. Mono meaning one. Examples: sodium ion, calcium ion, and aluminum are all cations because they're all positively charged. So the formulas for ions are written with the element symbol and a superscript with the positive and a number. You can also write a positive 1. You can also write the plus and then 2. So the order of the plus and the number doesn't matter, and you don't have to always write the 1. So the formulas are represented this way. So we know sodium has 11 protons. It now has 10 electrons. Calcium has 20 protons, and now it has 18 electrons. Aluminum ion has 13 protons, and now 10 electrons. Anions are negatively charged. They've gained electrons. So we have a chloride ion where it gained one more, so it has 17 protons and 18 electrons. It has an oxide ion, which normally would have 8 protons, now it has 10 electrons, and a nitride ion, which has 7 protons and 10 electrons. Those are called anions. Polyatomic ions are 2 or more atoms that are covalently bonded but have an overall charge. That means they have more electrons total than protons. So for example, ammonium is the only cation that's a polyatomic ion that we're going to study. So ammonium is 4 hydrogens covalently bonded to nitrogen, but it has 1 less electron. Nitrites, carbonate, and sulfate are all examples of anions. 2 oxygens and 1 nitrogen with 1 more electron than protons. 3 oxygens bonded to a carbon with 2 more electrons than protons. And 4 oxygens bonded to a sulfur with 2 more electrons to make an anion. So poly meaning 2 or more. Some common transition metals that you're going to need to know their formulas and their names for that we use throughout naming compounds called nomenclature and writing formulas. And these oxidation numbers on these ions become important because it tells us how many of these to bond with another element to form a compound. So these are the transition metals because they have multiple oxidation numbers in their oxidation and their d orbitals, and they can lose more than one set of valence. So iron 3 is +3, and they come from their old Latin stem names, ferrum. So the higher oxidation number is ic, the lower oxidation number is us. So +2 is iron 2, ferrous, from ferrum, the Latin name. Copper 2, cupric. Copper 1, cuprous, from cuprum. Cobalt 3, cobaltic. Cobalt 2, cobaltus. Tin 4, stannic. Tin 2, stannous, stannum. And then we have lead 4, plumbic. Lead 2, plumbus, from plumbum. And then we have mercury 2, mercuric, and mercury 1, mercurous. Notice that the formulas for mercury 1 and mercury 2 are a little different. Again, it's because mercury is that really odd element that's a liquid at room temperature. So you just got to know the formulas for mercury 2 and mercury 1. So this will be a resource sheet that I'll provide for you at the beginning of each unit because you'll need it going through forward to the rest of the year.